Hi, this video is going to be about DC to DC step down converters, also known as DC to DC buck converters. So I'm going to be explaining the working principle of the converters as well as how you can use them for some of your basic projects. So let us get started with this. Okay, so the question is, what does a DC to DC step down converter do? So if you're in electrical or electronics domain, you might be familiar with transformers. Transformers take in one input voltage and provide another voltage on the output. Based on the number of windings, the turns ratio on the primary and secondary, we get a different output from the input. So if you know a step down transformer takes a higher voltage on the primary winding and gives out a lower voltage on the secondary winding. So they are used in distribution substations, they are used in spot welders and arc welders and some of the older power supplies to feed into the rectifiers. So a DC to DC converter does the same thing with DC circuits. A transformer can only handle alternating current or AC. It cannot step down or step up direct current or DC. However, a DC to DC converter cannot step down or step up AC, it can only do it with direct current DC. So let us understand how it goes. So we feed an input DC voltage here. It may or may not be constant. It can be constant like it's from another supply, or it might be fluctuating like in case of a solar array or a DC generator. But the output will be a constant voltage which is set by tuning this potentiometer. Okay, so let me quickly explain the system, the things that are used in a DC to DC like a step down converter. The main component of this DC to DC converter is this MOSFET over here. Now this MOSFET is known as the LM2596 MOSFET, because of which this converter itself gets the name as LM2596 DC to DC converter. MOSFET is a very important part of the converter. This is a potentiometer which is used to change the duty cycle of the MOSFET and thereby give a desired output voltage. And these two capacitors are used for smoothing and filtering. This inductor also helps in little bit of filtering. So this capacitor and inductor here acts like an LC filter. There is an inductive capacitive filter to filter out the transients that may arise from the switching of this MOSFET, so as to make sure that we get a clean output. Moreover, it could also protect the DC to DC converters MOSFET from the inductive back EMF of loads like DC motors. Okay, so let me explain the working principle of a DC to DC converter in depth. Now, if I have a supply that is 12 volts, 12 volts is given as the input here, 12 volts is given as the input here, and now if I have a load here, let's say I use a load here, now this entire 12 volts goes to this load over here. This load over here gets the entire 12 volts. And let's say I add a switch in between this, that is we have 12 volts here, there is a switch and the load is here, and when the switch is on we get the full 12 volts. When the switch is off like this, we get 0 volts here. However, the way the DC to DC converter works is that this switch does not stay on or stay off. It doesn't stay in a 0 or 1 condition. It turns on, turns off, turns on, turns off multiple times. So based on that, we have a specific duty cycle at which that switch turns on and turns off. Duty cycle is the number of times the switch will turn on and turn off, and that is here we are not using a manual switch, we are using the MOSFET as a switch, and it gives a specific wave like this. When it's off it is 0, when it is on it is 1. It gives a square wave like this, and based on adjusting the duty cycle we can adjust the width of this pulse. when we adjust the width of this pulse, we can adjust the output voltage. Now if your DC to DC converter is a fixed voltage converter, the pulse width is constant, doesn't change at all. But if your DC to DC converter like the LM2596 is a varying converter, you can vary the duty cycle. For a higher voltage, let's say 5 volt output, this is the pulse, 5 volt. But if it's 3 volts, you could probably like reduce the pulse width, 3 volts. I mean, these are just rough examples. This is not how the exact waveform will look like. If you try it with an oscilloscope or any other advanced multimeter, it will show you the exact waveform. I'm just drawing it with an approximation. Okay, so the question arises as to what is the difference between a fixed duty cycle DC to DC step down converter and a variable duty cycle type converter. The difference is that if it's a fixed DC to DC step down converter, the duty cycle will be fixed. That is, the values of the inductor, the capacitor and the MOSFET will be pre-decided, and only these components will be fixed on the board. This MOSFET which is kept in between the input and the gate terminal of the MOSFET will not be there, and it will be connected without this potentiometer. It will be a fixed input and a fixed output. For example, like if you look at your car chargers, they will have a similar circuit. They can accept anywhere between 12 to 24 volts, like what I have seen, and it will give an output of, let's say, 5 volts or 9 volts, like depending on the type of charger, whether it supports fast charging and many other features. But they are an example of fixed type of step down converters where the duty cycle can't be varied. Output of 5 or 9 is constant, input is within this range. But here, this type of DC to DC converter is commonly used by electronics hobbyists for different projects, which is why we cannot keep purchasing multiple DC to DC converters for different values, 5 volt, 3.3 volts, 6 volts. We cannot do that, which is why this flexibility has been given with this potentiometer, so that we can tune it based on our requirement and then set a desired output voltage. Let me show how it is done. Now, let me just answer a question which many of you might be having during the video. What is the difference between both these converter boards? The thing is, both these converter boards are the same. Both of them are the LM2596 type DC to DC step down converters, but here are a few differences. This is the LM2596 type converter as it is commonly known. The board is smaller. It doesn't have any built-in voltmeter, nor does it have any latching circuit for measuring the input and output voltage. Besides, these terminals need to be soldered on or connected with crocodile clips. And if you are interested in pinning it onto a breadboard, then you need to add some breadboard terminals that again need to be soldered. This is known as the LM2596S. That is, there's an S after the LM2596. The board is technically the same. Electronic specifications are all completely the same. The only difference being that this one offers screw terminals which do not require soldering. Therefore, it is much more user friendly, both on the input and the output. Just need to screw it and screw in, screw out the connectors. You have a voltmeter here, but the problem is it's pretty inaccurate, at least for lower voltages. So that's why I recommend using a multimeter to measure the voltage rather than relying on this, or at least cross check it with a multimeter to see if it is a correct value. And this button over here is designed so that it can latch either on the input voltage or the output voltage. I will show it in this video, and besides I'll be using this to explain because it's much more user friendly in the remaining course of the video also. Okay, so now I have this lab bench power supply over here which is set to 5.3 volts on the output, and now I'm going to connect this to the input of this DC to DC converter to see how it gives the output voltage. Now I'm connecting these here, and see, this is the plus point of the 2596S because it has the screw terminals. I've connected jumper wires, which means I can interface it with the breadboard also quite easily. So the DC to DC converter has been turned on, and it is showing that it has an approximate voltage of, the voltage is fluctuating, but I've set it to 2.8 volts. Let me show it with a multimeter. Okay, so one quick note is, irrespective of whether you have a power supply or a DC to DC converter, always double check this value with a multimeter, because all these equipment are very inaccurate, and only the multimeter is capable of showing a correct value. Even the most expensive ones have the same error in them. Okay, so connecting the positive to the positive, negative to the negative, and if you see the multimeter, you can see that it's giving 2.78 volts as an output. So I had said this previously to charge two AAA batteries in the previous video, but this is how it can give a desired output. The 5 volts is a higher input voltage, 2.78 volts is the output which it's currently giving. Always make sure that the input voltage should be much higher than the output voltage, only then the converter will work. Now if I give below 3.5 volts, then the converter will not really give the desired output. It will not work at all. Only if the input voltage is higher than the desired output voltage, it will work properly. Okay, so I connected this multimeter to the output of the DC to DC converter through alligator clips, and let me show you how we can change the output voltage. Now, like I said, since the input voltage is 5 volts, any voltage between 1.5 to 4.8 volts can be achieved on this DC to DC converter. That's the way it can be done. So the characteristics are like 3 volts to 50 volts can be taken as the input, and 1.25 to 40 volts can be taken as the output, provided the input voltage is always higher than the output. This is what the data sheet says, but I have not tested it so far. Be careful while you test these converters, because sometimes they may not be able to work at such high voltages. Do be careful and try it at your own risk. I'm not responsible if anything goes wrong. Okay, with the disclaimer out of the way, let us see how we can change the voltage. Now, I'm using a flathead screwdriver and tuning the potentiometer. Now, if I tune the potentiometer to the clockwise direction, I can reduce the voltage. Like you see, it's reducing on the multimeter. Whereas when I turn it anti-clockwise, it's increasing the voltage. So let us see the decrease. Now we are approximately at 1.5 volts, and now let me get it to a higher voltage. I'm tuning anti-clockwise. Of course, it might vary with the different models. The potentiometer might be placed differently. Just test it with a multimeter. It will help in achieving the result. So you can go up to, let's say, 3.9 volts almost. Yeah, so let me just set it back to the desired voltage of 2.8 volts, because I'm using that with one of the other circuits. So I'm setting it back to like 2.8 volts. Like you see, this voltmeter here is notoriously inaccurate, so that's why I only trust the multimeter over here. Let me get it back. Yes. Now, one feature which I observed over here is that if you press this button, you see that the voltage shows almost 4.7, because the voltage input is around 5 volts, so it is showing the input voltage. Now if I press this again, it's showing the output voltage. Input voltage, output voltage. But I don't see much point in this because this meter is inaccurate. So only if it's accurate will this feature be useful. So my recommendation is that this voltmeter should be changed in order to avail the feature. But what I like about the 2596S is that we have the screw terminal, so no need to solder, and we the board is like much better to handle. Okay, so this video would have been quite theoretical and there wouldn't have been much practicals here. Main reason being that I wanted to explain the DC to DC converter, step down converter basics to the viewers, which is why this video has been a lot more theoretical. But I'll surely use these converters in some practical applications in the upcoming videos so that you can get a better understanding of how it can be used, as well as you could use it to build some of your own projects or your circuits based on the requirement. So with that, I'm concluding this video for now. Thank you so much for watching. Like, comment, share and subscribe. Stay tuned. I'll see you in the next video.